Hello everyone, welcome back to Maths Marathon classes. In this session, I'll be discussing some of the important formulas and concepts of the topic parabola, which will be helpful for various competitive exams. Okay, we'll start from the general second degree equation here. The general second degree equation is given by this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. The general second degree equation. The general second degree equation. The general second degree equation is given by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is called the general second degree equation. This will represent a parabola, will represent parabola if delta is not equal to 0, will represent a parabola if delta is not equal to 0 and h square minus ab is equal to 0. H square minus ab equal to 0. This is the condition for the general second degree equation to represent a parabola. What is delta? Delta is called the discriminant. It's given by delta refers to the discriminant of this quadratic, where delta is given by ABC plus 2FGH minus AF square minus BG square minus CH square. Delta is given by this. Or I can write delta in terms of determinant also. Or I can write delta is equal to determinant of AHG HBF GFC. Delta is determinant of this. AHG HBF GFC. If you want, you can expand this, you'll get this. A into BC minus F square minus H into HC minus GF. Correct? Plus G into HF minus BG. If you want, you can expand it, you'll get the same equation. Delta in terms of determinant also is given here. Okay. And the eccentricity of the parabola is 1. Also will explain the different terms involved in conics here. Different terms involved in conics. Different terms involved in conics. Axis, the first one is the axis of the parabola, axis of the conic. Okay, axis of the conic. Axis is a straight line which is passing through the focus and it is perpendicular to directrix. It is a straight line passing through the focus. It is a straight line passing through the focus. Straight line passing through the focus. Passing through the focus and perpendicular to the directrix. And perpendicular to the directrix. Second one, I'm going to give the vertex. Vertex is the point of intersection of the axis of the conic and the conic. Okay. It is the point of intersection of. It is the point of intersection. POI, right? POI is the point of intersection of the axis and the conic. Point of intersection of the axis and the conic, where the conic is going to intersect the axis. Such points of intersection are called as the vertex or vertices sometimes. Next one, the focal chord. The chord which passes through the focus is called the focal chord. The chord which passes through the focus. Chord which passes through the focus is called as the focal chord. Any chord which passes through the focus is called as focal chord. Next we got double ordinate. The chord which is perpendicular to axis or the chord which is parallel to directrix is called as double ordinate. Double ordinate. The chord which is parallel to directrix. The chord which is parallel to directrix. Or I can tell the chord which is perpendicular to the axis is called as double ordinate. Or the chord which is perpendicular to axis, perpendicular to the axis of the conic is called as the double ordinate. Next we got the lattice rectum. The focal chord which is parallel to directrix is called as the lattice rectum. The one focal chord, many focal chords we can draw. Any chord which passes through the focus is called as focal chord. The one focal chord which is parallel to the directrix is called as lattice rectum. The focal chord which is parallel to directrix. The focal chord which is parallel to directrix. The focal chord which is parallel to directrix. Which is parallel to directrix is called as the lattice rectum. Next we got the center of the conic. Center is the point where every chord passing through it is bisected at that point. It is a point where every chord passing through it is bisected at that point. It is a point where every chord passing through it, every chord passing through it is bisected at that point. Is a point where every chord passing through it, every chord passing through it is bisected at that point. Passing through it is bisected at that point. In fact, the parabola does not have center. Other conics like ellipse and hyperbola, even circle has a center. Parabola does not have a center because every chord which is passing through it should be bisected at that point. Such a point is called as center. It is a point where every chord passing through it is bisected at that point. Okay, any chord passing through it should be bisected at that point. That point should become the midpoint of the end point of the chord. Such a point is called as center. So these are different terms involved in conic section. Next, I'll tell you a method to find the center of a conic which is not there for parabola. Parabola does not have a center, of course, correct? You consider the general second degree equation to find the center of a conic. To find the center of a conic, I'll give you a method here. It's quite useful. To find the center of the conic. To find the center of the conic. Of course, the parabola does not have a center. Given the second degree equation, the general second degree equation is given to you. Suppose they give this equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. The general second degree equation. The general second degree equation is this. What we do is we differentiate this partially with respect to x once, then differentiate with respect to x, differentiate with respect to y partially. Then find the points of intersection of those to get the center of the conic. Differentiate this equation star with respect to x partially. Differentiate with respect to x partially. Differentiate the equation star with respect to x partially. With respect to x partially. When you're differentiating with respect to x partially, we treat y as a constant. So derivative of ax square is 2ax. Derivative of 2hxy. 2hy is constant, x derivative is 1. Correct? Constant into variable. How to differentiate? Constant keep as it is. Differentiate x1. 2hy is constant. 2hy is constant. Derivative of x1. Derivative of by square is 0. Derivative of 2gx is 2g. 2g into 1. Derivative of 2fy is 0. Derivative of c is 0. Equal to 0. So what I get is, I can write this as, divide the entire equation by 2 and write ax plus hy plus g is equal to 0. Call this equation 1. Same way, differentiate the equation star with respect to y partially. When you differentiate with respect to y partially, keep x as constant. Treating x as constant. Differentiate with respect to y partial. Differentiate the equation star with respect to y partially. What we get? Ax square is constant because x is constant, derivative of constant is 0. Derivative of 2hxy. 2hx is constant, derivative of y is 1. Derivative of y with respect to y is 1. 2hx. Derivative of by square is 2by. Of course, a, h, b, g, f, c are constants anyway. The variables are x and y. When you differentiate with respect to x, partially keep y as constant. When you differentiate partially with respect to y, keep x as constant. Okay. Derivative of 2gx is 0. Derivative of 2fy is 2f. Derivative of c is 0. Equal to 0. So you divide the entire equation by 2 and write hx plus by plus f is equal to 0. Call this equation 2. Correct? Here we got ax plus hy plus z equal to 0. Here hx plus by plus f equal to 0. If we solve equations 1 and 2, find the point of intersection. Point of intersection of 1 and 2. POI, I'll write. POI of 1 and 2 gives point of intersection of 1 and 2. We get HF minus BG divided by AB minus H square. GH minus AF divided by AB minus H square. Point of intersection of these two. The remembering method is there for this. The remembering method is how fast boys and girls go home after film. HF minus BG by AB minus H square. GH minus AF by AB minus H square. How to remember? How fast boys and girls go home after film. AB minus H square. You can remember my name is Abhiram. Whenever they put the timetable in many of the institutions, what they do is in the short form they write my name as ABH. Abhiram, ABH they write. Many of the institutions, whenever they put my class, my name is there in the timetable, they write ABH. So ABH you can remember. Okay. So one of the beautiful method to find the center of a conic given the second degree equation. The general second degree equation is given to you. How to find the center of a conic is this method. Okay. So we can differentiate, otherwise directly you can use this formula also. Compare the general second degree equation and apply this formula, or else you differentiate with respect to x and y partially and solve the two equations, you'll get the answer. Any method you can do. Next we'll go to Of course, the parabola does not have a center. The basic definition of the parabola will go now. The eccentricity of the parabola is going to be 1, okay? And the equations of the parabola in the standard form will derive, I mean not derive, just tell you and name the parts, different parts of the parabola. The parabola is defined as the locus of the point which moves such that distance from the fixed point to distance from fixed line is a constant ratio which is 1. Correct? The point P moves such that the parabola is this x-axis, origin, y-axis. The focus is here, yes, a comma 0 will call the focus. The point P moves such that distance from the fixed point to distance of fixed line is constant. SP by PM is constant. This is the directrix. The fixed line is called as directrix and the fixed point is called as the focus. SP by PM is 1. SP divided by PM is equal to E. E is 1. E is 1. E is the eccentricity of the conic. SP is equal to PM. SP by PM is E. E is 1. For parabola, eccentricity is 1. Cross multiply, SP is equal to PM. We get SP is equal to PM. The point P moves such that distance from the fixed point is equal to distance from the fixed line. The standard form of the equation of the parabola is y square is equal to 4ax. Y square is equal to 4x is the standard form of the equation of the parabola. For this parabola, the vertex is at origin. Focus lies on x-axis. Directrix is the vertical line, x equal to minus a can call. And the axis is x-axis. The parabola is symmetric with respect to x-axis. This is the axis of the parabola. Axis of the parabola. This is the focus of the parabola. Focus is a comma 0. And this is the vertex. The origin is the vertex. Origin is the vertex. And this is the directrix. Directrix is x is equal to minus a. Directrix is x is equal to minus a. Vertex is at the origin. Focus is on the x-axis. Directrix is vertical line. Okay. And the focal chord which is parallel to directrix is the lattice rectum. This is the lattice rectum of the parabola. LR we can call. Lattice rectum. For the parabola, y square is equal to 4x. We can remember that the focus lies on x-axis. Focus lies on x-axis. For this parabola, what are the important things? Focus lies on x-axis. Vertex is at origin. Vertex is at origin. Vertex is at origin. Eccentricity of any parabola is always 1, that you know. The focus lies on x-axis. Directrix is vertical line. Directrix is vertical line. Directrix is vertical line. Then we can write that directrix is perpendicular to the axis. Correct? Axis is x-axis. Axis is x-axis for us. Axis is x-axis. Directrix is perpendicular to the axis. Directrix is perpendicular to the axis. And focal distance is mod of x plus a for this. Focal distance. Focal distance means distance from the focus to any point on the parabola. Focus is a comma 0. Any point on the parabola can take x comma y. If you find the distance SP, the focal distance is going to give mod of x plus a. Focal distance is mod of x plus a. And eccentricity of the parabola is 1. Eccentricity is 1. And the length of the lattice rectum is the double the distance between the focus and the directrix. Length of the lattice rectum we get. The parametric equations also I can tell x equal to 80 square, y is equal to 80. The parametric equations are x is equal to 80 square, y is equal to 280, where t is the parameter. parametric equations are given by x is equal to at square, comma, y is equal to 2at. Length of the lattice rectum is LLR, I call. Length of the lattice rectum is 2 times the perpendicular distance between the focus and the directrix. 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 And the vertex is going to be the midpoint of the focus and the foot of the perpendicular drawn from the vertex to directrix. Okay, that is another thing. The vertex is midpoint of. Vertex is the midpoint of. Vertex is the midpoint of focus and the foot of the perpendicular drawn from foot of the perpendicular drawn from the vertex to directrix. Vertex to directrix. Many times these things are useful in working out the problems. That's why I've given it. Okay. So I marked the different parts of the parabola: focus, axis, vertex, lattice rectum, directrix. Okay. For y square is equal to 4x. Please make a note of this. And t is a parameter here. X equal to 80 square, y is equal to 80 when t is a parameter. And for x square is equal to 4ay, the parabola is rotated. It has axis along y-axis. X square is equal to 4ay is a parabola like this. X square is equal to 4ay, something like this. For this, the axis is going to be y-axis. Symmetric with respect to y-axis. X square is equal to 4ay. Of course, a is positive. A is positive means it is opening upwards. If A is negative, it opens downwards. And the focus will lie on y-axis. Focus is yes, 0, comma A. Directrix is here. Y is equal to minus A. The equation of directrix. Y is equal to minus A. Directrix is going to be a horizontal line. Lattice rectum is, of course, it is passing through the focus and it is parallel to directrix. X square is equal to 4ay. So opening upwards, symmetric with respect to y-axis. And for this, the focal distance is mod of y plus a for this parabola. Focal distance is mod of y plus a. And the parametric equations are going to be x equal to 280, y equal to 80 square. For this parabola, I'll write only 2 points, not everything, because it is almost similar. I can tell orally, focus lies on y-axis and axis is y-axis. The directrix is a horizontal line. Okay, vertex is at origin. Eccentricity is 1, of course. Then focal distance is mod of y plus a. The parametric equations are x equal to 280, y equal to 80 square. Okay, the parametric equations. Parametric equations for this parabola: x square is equal to 4ayr, x square is equal to 4ayr, x is equal to 280 and y is equal to 80 square. There it was x equal to 80 square, y is equal to 280, x equal to 80 square, y is equal to 280 for this parabola. For this, x is equal to 280, y equal to 80 square. Okay, a is a constant and t is a parameter. Focal distance is mod of y plus a. Eccentricity is 1. Okay, and the rest, the focus is distance between the focus and the directrix. If you find double of that, that gives the length of the lattice rectum. All those points are there actually. Okay, the distance between the focus and the directrix. If you double that, what you're going to get is the length of the lattice rectum. That is same as we had here. Okay. And also the vertex is going to the midpoint of the focus and the foot of the perpendicular drawn from the vertex to directrix. All those things, even it is true here. I'll write the different components of parabola in the form of y square is equal to 4x, x square is equal to 4ay, and also in the shifted form and the rotated and shifted form. The four parabolas I'm going to write. Y square is equal to 4x, the first one. The parabola, we have the parabola y square is equal to 4x. I'll write the vertex, focus, the equation of directrix, all those things. For y square is equal to 4ax. The vertex is at origin. The vertex is at origin. Focus is a comma 0. Focus for this parabola is a comma 0. Equation of directrix is x is equal to minus a. Equation of directrix is x is equal to minus a. And eccentricity is 1 for any parabola, that I won't write here. Okay. Next on axis I'll write. Axis is x-axis. Equation of x-axis is y equal to 0. Vertex, focus, directrix, axis. Then we got endpoints of lattice rectum. Before that, equation of lattice rectum I'll write. Equation of the lattice rectum. LR I'll write. LR or full I'll write. Lattice rectum. Equation of the lattice rectum is x is equal to a. Endpoints of the lattice rectum. Endpoints of the lattice rectum is a comma plus or minus 2a. Endpoints of the lattice rectum is a comma plus or minus 2a. Finally, length of the lattice rectum. Length of the lattice rectum is 4 mod a. Length of the lattice rectum is 4 mod a. This is the first one. Vertex, focus, directrix, axis, equation of lattice rectum, endpoints of lattice rectum, and length of the lattice rectum. Y square is equal to 4x. Next I'll write for x square is equal to 4ay. This is the parabola which is rotated about the origin, which has axis along y-axis. Correct? Vertex is at origin. Focus lies on y-axis 0 comma a. Directrix is y is equal to minus a. Axis is y-axis whose equation is x is equal to 0. Equation of lattice rectum is y is equal to a. Endpoints of lattice rectum plus or minus 2a comma a. Length of the lattice rectum is 4 mod a. Next we'll write y minus k the whole square is equal to 4a into x minus h. The parabola in the shifted form we can call this. Y minus k the whole square is equal to 4a into x minus h. This parabola is got from this parabola by shifting the vertex from 0 comma 0 to h comma k. So vertex will be at h comma k here. Vertex will be at h comma k. Axis focus will be a plus h comma k. Add h to x coordinate, add k to y coordinate from this parabola. Add h to x coordinate, add k to y coordinate. Directrix x equal to minus a becomes x is equal to minus a plus h. Axis y-axis, x-axis whose equation is y equal to 0 becomes y is equal to k now. Y is equal to k. Equation of lattice rectum was x equal to a. Now it becomes x equal to a plus h. Endpoints of lattice rectum a comma plus or minus 2a becomes a plus h comma k plus or minus 2a. Length of the lattice rectum is same in all the parabolas, 4 mod a. This is shifted form of the parabola which is shifted and got from this parabola. Y square is equal to 4x. This parabola is shifted and we get x minus h the whole square equal to 4a into y minus k for this. This parabola is x minus h the whole square is equal to 4a into y minus k. Looking at this, I'll write vertex was 0 comma 0, it becomes h comma k. Add h to x coordinate, add k to y coordinate. focus was 0 comma a, it becomes h comma a plus k. H comma a plus k. Directrix y is equal to minus a becomes y is equal to minus a plus k. Okay. Axis was x equal to 0. Now it becomes x is equal to h. Equation of lattice rectum y is equal to a becomes y is equal to a plus k. Endpoints of lattice rectum plus or minus 2a comma a becomes h plus or minus 2a comma a plus k. And the length of the lattice rectum is 4 into mod a. Okay, please make a note of this. Different parabolas, different forms of the parabolas are given here. Please make a note of this. Next one. The parabola is given in this form. Result. The parabola takes this form. Ax square plus bx plus c equal to 0. If it is quadratic in x, not like this. If it is given in this form, ax square plus bx, by, all right, x square plus by, ax square plus by plus cx plus d equal to 0. The equation of the parabola is like this. Then the length of the lattice rectum is LLR, length of the lattice rectum is mod of coefficient of y by coefficient of x square. Coefficient of y by coefficient of x square. Coefficient of y by coefficient of x square. This is mod of b by a. Mod of b by a. If the parabola takes this form, suppose I give quadratic in y, ay square plus bx plus cy plus d equal to 0, then length of the lattice rectum is mod of coefficient of x by coefficient of y square. Coefficient of x divided by coefficient of y square. Coefficient of x by coefficient of y square. This is mod of b by a. Parabola takes quadratic in x here. This is quadratic in y. Coefficient of x by coefficient of y square. Here coefficient of y by coefficient of x square. Please make a note of this. Because in y square is equal to 4ax, what we have is y square is equal to 4ax. What is coefficient of x by coefficient of y square? That is 4a, which is nothing but the length of the lattice rectum, right? Coefficient of x by coefficient of y square. Coefficient of x divided by coefficient of y square. Coefficient of x is 4a, coefficient of y square is 1. If we take mod of this, what we get is the length of the lattice rectum, correct? Which is nothing but 4a by 1. Mod of 4a by 1. Even if we take x square is equal to 4a by, what is length of the lattice rectum? Mod of 4a, correct? Which is coefficient of y by coefficient of x square. So coefficient of y by coefficient of x square gives the length of the lattice rectum. Coefficient of y divided by coefficient of x square. Which is mod of 4a. Next, we can discuss about the parametric relationship between the endpoints of the focal chord. Before that, I mentioned about the parametric equations already, correct? Already mentioned about the parametric equations for both the parabolas, correct? So I can go to focal distance is also mentioned. No, I can go to the parametric relationship between the endpoints of the focal chord. Parametric relationship between the endpoints of the focal chord. Parametric relationship between the endpoints of the focal chord. Between the endpoints of the focal chord. Focal chord means the chord which always passes through the focus is called as focal chord. The parametric relationship between the endpoints of the focal chord. If you know one end of the focal chord, we can write the other end of the focal chord using this. Consider the parabola in the form of y square is equal to 4x. Y square is equal to 4x. Focal distance is mod of x plus a. Focus is yes, a comma 0. This is called the focal chord. PQ is the focal chord. Okay, directrix is here. X is equal to minus a is the equation of the directrix. So PQ is the focal chord. Okay, so if you know one end of the focal chord as 80 square comma 280, other end of the focal chord is got by replacing t by minus 1 by t. So PQ is the focal chord in this. PQ is a focal chord. If you know one end of the focal chord, we can find the other end of the focal chord. If P is 80 square comma 280, P is 80 square comma 280, that is one end of the focal chord is 80 square comma 280, then other end of the focal chord is, then Q is gone by, replace T by minus 1 by T, A by T square, A by T square comma minus 2A by T. One end of the focal chord is 80 square comma 280, other end of the focal chord is a by t square comma minus 2a by t. In other words, I can tell that if p is a t1 square comma 2a t1, p is a t square comma 2a t1, and q is a t2 square comma 2a t2, then what we have is T1 into T2 is equal to minus 1. What satisfies the relationship between T1 and T2 is such that T1 into T2 equal to minus 1. Okay, product of T1 and T2 should be equal to minus 1, or T2 is minus 1 by T1. In same as well, T is replaced by minus 1 by T, so that we get the other end of the focal chord. It's very important concept. Many times questions are asked based on this for JEE exams. So one end of the focal chord is 80 square comma 280. Other end of the focal chord is a by t square comma minus 2a by t. Remember this. Also I can speak of the segments of the focal chord. SP and SQ are called as segments of the focal chord. Segments of the focal chord are given by a plus at square and a plus a by t square. The segments of the focal chord. Important points connected to the segments of the focal chord. The segments of the focal chord are given by the segments of the focal chord. Segments of the focal chord are SP, I'll call SP. Focal chord is PQ. Focal chord PQ, I'll call. PQ is the focal chord. Okay. Segments are SP and SQ, where S is the focus. Where S is the focus. SP is equal to A plus AT square and SQ is A plus A by T square, where S is the focus. S is the focus of the parabola. Next, the harmonic mean, if you find of the segments of the focal chord, is going to be the semi-lattice rectum of the parabola. The harmonic mean of the segments of the focal chord. The harmonic mean, HM, of the segments of the focal chord. The harmonic mean of the segments of the focal chord is the semi-lattice rectum, is the length of the semi-lattice rectum of the parabola. is the length of the semi-lattice rectum of the parabola. Length of the semi-lattice rectum of the parabola. We can write mathematically that 1 by SP plus 1 by SQ is 1 by A. That is, we can write like this: 1 by SP plus 1 by SQ, 1 by SP plus 1 by SQ is 1 by A. Or I can write 2 times SP into SQ, 2 times SP into SQ divided by SP plus SQ. The harmonic mean is going to be 2A, 2 into mod AL, right? Or I can write this as 4 times SP into SQ, 4 times SP into SQ divided by SP plus SQ is going to be the length of the lattice rectum multiplied by 2 on both sides, because 4 mod A is the length of the lattice rectum, right? We get like this. And the length of the focal chord is A into T plus 1 by T the whole square. That is also quite important. Length of the focal chord. Length of the focal chord is, in terms of the parameter T, is length of the focal chord is A into T plus 1 by T the whole square. Learn this. Questions are asked based on this. A into T plus 1 by T the whole square. Or I can also write it as length of the focal chord as A into T2 minus T1 the whole square, where T1 and T2 are the parameters. Length of the focal chord is also given by length of the focal chord is A into T2 minus T1 the whole square. T1 and T2 are the parameters. Also, I can write the length of the focal chord as 4A cosecant square alpha. Length of the focal chord is, length of the focal chord is 4A cosecant square alpha, where alpha is the angle made by the focal chord with the positive x-axis. 4A cosecant square alpha. Something like this. The parabola is there. Y square is equal to 4AX. It makes an angle alpha with positive x-axis. Focus is here. It makes an angle alpha. Focus is yes, A comma 0. This is the angle made by the focal chord PQ with the positive x-axis. In that case, we have the length of the focal chord as 4A cosecant square alpha. This is the directrix whose equation is x is equal to minus A. So length of this focal chord, which makes an angle alpha with positive direction of x-axis, is 4A cosecant square alpha. Also, if a perpendicular is drawn from the vertex to this focal chord, vertex is of course origin. Draw the perpendicular like this. Okay, this angle is alpha, then this angle is also alpha. Okay, both the angles are equal to alpha only because of, we know that vertically opposite angles are equal. Correct? This angle is also alpha. So in this triangle, I can define, this is OM I'll call. In triangle OSM, in triangle OSM, I can define cosec alpha. Cosec alpha is hypotenuse by opposite side. We know OS is A, correct? OS is A and OM is, I'll call D here. OM is D. Okay, if you define cosec alpha is hypotenuse by opposite side, because this angle is 90 degree, because I have drawn a perpendicular from the vertex to the focal chord, this becomes 90. So hypotenuse is OS and D is going to be the opposite side, correct? So I can define cosec alpha in triangle OSM. Cosec alpha is opposite to 90 is hypotenuse, OS is hypotenuse, OS divided by OM, correct? OM is the opposite side. So cosec alpha is A divided by D. OS is A and this I have taken as D. So I can write cosec alpha as A by D. So length of the focal chord I can write it as 4A into cosec alpha is A by D. Also I can write the length of the focal chord, substituting the value of cosec alpha. Length of the focal chord is equal to 4A into Cosecant alpha is a by d. A by d the whole square. So what you get is 4a into a square divided by d square, which is 4a cube divided by d square. Correct? Length of the focal chord is 4a cube by d square. A is the value of a from the parabola. Distance from the vertex to focus is a. This length is a, we know. Correct? This length is a. From O to S, distance is a. This is d. So cosec alpha I define. Cosec alpha is hypotenuse by opposite side. Opposite to 90 is hypotenuse. So OS is hypotenuse and OM is the opposite side. So a by d. Cosec alpha is a by d. Substitute. So 4a cube by d square. A is got from the parabola and the d is the distance from the vertex, the perpendicular distance from the vertex to the focal chord. Even in J exam 2024, two such questions are asked based on this J exam. This question, this type of formula was useful in J 2024. Two questions were asked based on this. Even in 2024, this formula is used in one of the questions. Okay, so please make a note of this. There are many things are given about the focal chord, length of the focal chord, segments of the focal chord, parametric relationship between the endpoints of the focal chord, all those things. And of course, the shortest focal chord is going to be the lattice rectum. That's another important thing. The shortest focal chord of the parabola is the lattice rectum. The shortest focal chord. The shortest focal chord of the parabola is the lattice rectum. Is its lattice rectum. The shortest focal chord that you can prove using the AMGM inequality. Okay. The shortest focal chord of the parabola is its lattice rectum. Segments of the focal chord are a plus at square and a plus a by t square. That is also important. One question is asked even in 2025. Okay, based on it. Segments of the focal chord a plus at square and a plus a by t square. Harmonic mean on the segments of the focal chord is the length of the semi-lattice rectum. Length of the focal chord is a into t plus 1 by t the whole square. Also a into t2 minus t1 the whole square. Length of the focal chord. In terms of angle alpha, it is 4a cosecant square alpha. And in terms of a and d is the distance from the vertex to the focal chord. D is the perpendicular distance from the vertex to the focal chord. Then length of the focal chord is 4a cube by d square. All these things you must know. Okay. Next, I'm going to discuss the one of the important results here. If an equilateral triangle is inscribed in the parabola with one vertex at the vertex of the parabola, then the length of the side of the equilateral triangle is 8a root 3. One of the important results here. Already one question was asked earlier in J exam. If an equilateral triangle is inscribed in the parabola, if an equilateral triangle is inscribed in the parabola, if an equilateral triangle is inscribed, in the parabola, y square is equal to 4ax. If an equilateral triangle is inscribed in the parabola, y square is equal to 4ax with one vertex of the triangle at the vertex of the parabola. With one vertex of the triangle, is at the vertex of the parabola. Then the length of the side of the equilateral triangle is length of the side of equilateral triangle is 8a root 3. Length of the side of equilateral triangle is 8a root 3. An equilateral triangle is inscribed in the parabola. This parabola is y square is equal to 4ax. Each of this angle is 60 degree we know in an equilateral triangle. Correct? Length is same. All the sides are equal and all the angles are equal to 60 degree. Length of the side of the equilateral triangle, which is inscribed in the parabola y square is equal to 4x, with one vertex of the triangle at the vertex of the parabola. Length of the side is 8a root 3. Length of the side is 8a root 3. Remember this. Okay, the figure looks like this. You can prove it. Proof is not given in this session. Okay, separate videos will be done for the proof. I am discussing only formulas, revising all the formulas and concepts. Next, the position of the point with respect to the parabola. Position of the point with respect to the parabola. You consider the parabola y square is equal to 4ax and a point px1 y1. Okay, consider the point px1 y1. Consider a point px1 y1. Consider a point px1 y1 and the parabola y square is equal to 4ax and the parabola y square is equal to 4ax. Okay, if we consider the parabola y square is equal to 4x and the directrix x is equal to minus a, point P is given, y square is equal to 4ax. If we substitute the point in the equation of the parabola, if y1 square minus 4ax1, if this is positive, then the point P lies outside the parabola. The point P lies outside the parabola. Point P lies outside the parabola. If y1 square minus 4ax1 is less than 0, then the point P lies inside the parabola. The point P lies inside the parabola. Inside this, it lies. If this quantity is negative, less than 0 means negative. Point P lies inside the parabola. If y1 square minus 4ax1 is equal to 0, y1 square minus 4ax1 is equal to 0, then the point P lies on the parabola. Point P lies on the parabola. Please make a note of this. Position of a point relative to the parabola. Inside the parabola means it is containing the origin here, the vertex, in fact, inside this region. On the parabola means this quantity is equal to 0. Less than 0 means inside. Greater than 0 means outside the parabola. Next, we discuss about the tangent and normal we can discuss. Even though it's deleted, we can discuss a bit about tangent and normal, writing the equations of tangent and normal to parabola, different forms, point form, slope form and the parametric form. Okay, because many times questions are asked, even though it's deleted, these concepts are required. Okay, tangent and normal to parabola. Tangent will write tangent to parabola first. Tangent to the parabola. If we consider y square is equal to 4ax, the equation of tangent is got by replacing y square by y by 1, x by x plus x1 by 2. For y square is equal to 4ax if you take. For y square is equal to 4ax. First one I am writing is the point form. 4ax is equal to 4ax The point form of the equation of the tangent. Point form is replace y square by y1, y square becomes y1, x becomes x plus x1 divided by 2, x plus x1 divided by 2, 2 cancels, or I can write this as y into y1 is equal to 2a into x plus x1, equation of tangent to parabola in the point form. Second one we got in the parametric form. Parametric form of the equation of the tangent is yt is equal to x plus at square. The parametric form. Parametric form is given by y into t is equal to x plus at square. The equation of the tangent to parabola in the parametric form where t is the parameter. Third one is the slope form. Slope form is given by y is equal to mx plus c where c is a by m. This is slope form of the tangent to parabola. Y equal to mx plus c, c is a by m. Next, same I can write the point of contact also. The point of contact, point where the line touches the parabola is called as point of contact of the tangent, which is a by m square comma 2a by m. Point of contact is point of contact, I'll write. Point of contact. Point where the line becomes the tangent to the parabola. Point of contact is a by m square comma 2a by m. A by m square comma 2a by m. This is the point of contact. This is for y square is equal to 4x. Next I can write for x square is equal to 4ay. For x square is equal to 4ay, the equation of tangent in the point form is got by replacing x square by x1. Y is replaced by y plus y1 divided by 2. Y plus y1 divided by 2. Or I can write this as x into x1 is equal to 2a into y plus y1. Second one, the parametric form. Parametric form is in terms of t I am writing. The parametric form of the equation of the tangent. Here it was yt is equal to x plus at square. No, this becomes xt is equal to y plus at square. The parametric form. Next one is the slope form. Slope form of the equation of tangent is to this parabola. Y is equal to mx plus c. C is minus am square. The condition for tangency C is a by m. Here condition for tangency C is minus am square. And the point of contact is 2am comma am square. Point of contact is 2am comma am square. Please make a note of writing the equations of tangent to y square is equal to 4x and x square is equal to 4ay in point form, in parametric form, slope form, and also the point of contact. Okay, this is tangent to parabola. Next I'll go to normal to parabola. Any line which is perpendicular to tangent is called as normal. Normal to any curve. Normal to parabola I'll write now in different forms. First I'll write to y square is equal to 4x. Next I'll write to x square is equal to 4ay. Normal to the parabola. Normal to the parabola. Y square is equal to 4x first. For y square is equal to 4ax, the equation of normal in the point form. Point form is. It doesn't simplify to a proper form. Still I'll write it. Y minus y1 is equal to slope of the tangent is how much? Dy by dx is slope of tangent. So if you differentiate this 2y y dash, here you get 4a into 1. Correct? 2y y dash equal to 4a. That means y dash is 2a by y. If you differentiate that, what I get? 2y into y dash is equal to 4a. So y dash is equal to 2a divided by y. This is slope of tangent. Slope of normal is minus negative reciprocal is minus y1 by 2a. minus y1 by 2a into x minus x1 I can write. Minus y1 by 2a, negative reciprocal of this, minus y1 by 2a into x minus x1. It doesn't simplify to the proper form, so keep as it is. This is slope of tangent. Slope of normal is negative reciprocal of this, putting y as y1 and writing. Okay, so if you can't remember everything, can get there itself. This is equation of normal to the parabola in the point form. Next one I go for the parametric form. The parametric form of the equation of the normal is, the parametric form is given by y plus tx is equal to 2at plus at cube. Y plus tx, y plus tx is equal to 2at plus at cube. Equation of normal to the parabola in the parametric form. Next we got slope form. Slope form of the equation of the normal. Slope form is y is equal to mx plus c, where c is minus 2am minus am cube. Minus 2am minus am cube. Equation of normal to parabola in the slope form. And the point of contact is got from the tangent. Point of contact. Point where the line becomes normal to the parabola. Point of contact is, point of contact of tangent was a by m square comma 2a by m. No, there you replace m by minus 1 by m. So we get am square. A by m square becomes am square. 2a by m becomes minus 2am. Remembering method is there actually, correct? So here you replace m by minus 1 m. A by m square becomes a into m square. 2a by m becomes minus 2am. Okay, this is the method of writing the point of contact of the normal. For x square is equal to 4ay, for x square is equal to 4ay, for this parabola, the point form is normal equation I am writing here in the point form. Point form of the equation of normal is y minus y1 is equal to, here if you differentiate this, I'll get slope of tangent. No, 2x is equal to 4a y dash. So y dash is going to be x by 2a. Correct? If you differentiate this, 2x is equal to 4a into y dash, or y dash is equal to how much I get? X by 2a. X by 2a. This is slope of tangent. Slope of normal is negative reciprocal of this. So minus 2a divided by x1. There it was minus y1 by 2a. Here minus 2a by x1 into x minus x1. Instantly you can get. Doesn't take much time, even though we can't remember it. Okay. This is point form. Second one is the parametric form. Parametric form. Parametric form is, there it was y plus tx is equal to, y plus tx equal to 2at plus at. From there we can get the parametric form, which is x plus ty, x plus ty is equal to 2at plus at cube. 2at plus at cube. Equation of normal in the parametric form. In the slope form we have y is equal to, slope form of the equation of normal is, slope form, slope form is y is equal to mx plus c. C is 2a plus a by m square. 2a plus a by m square. And the point of contact is, point of contact of this is got by, there we had 2am comma am square. For x square is equal to 4a by, point of contact of tangent is 2am comma am square. There you replace m by minus 1 by m. So you get minus 2a by m. 2am becomes minus 2a by m. Am square becomes a by m square. Replace m by minus 1 by minus. In this you replace m by minus 1, 2a by minus m. That is minus 2a by m comma a by m square. Okay, point of contact. Please learn all these things. This is am square comma minus 2a. Correct, no? Hope it's clear. This is am square. Am square comma minus 2a. So equations of tangent to parabola for y square is equal to 4x and x square is equal to 4ay in different forms. I have written point form, slope form as well as parametric form. Also I wrote the point of contact. And here I wrote the equations of normal in different forms. Slope form, point form and the parametric form. Okay. And also the point of contact is given. Next I'll write the equations of tangent and normal to the parabola y minus k the whole square equal to 4 into x minus h. For this parabola, y minus k the whole square is equal to 4a into x minus h. I'll write the equation of the parabola, equation of tangent and normal to this parabola in only slope form. Okay, tangent in the slope form is tangent to this parabola in the slope form. How to write for this parabola? Y minus k is equal to m times x minus h plus c. C is a by m. Okay, normal to this parabola is got by writing like this: y minus k is equal to m times x minus h, correct, plus c is minus 2am minus am cube. This is the equation of normal to this parabola. Y minus k the whole square equal to 4a into x minus h. Next I'll go to the parabola x minus h the whole square equal to 4a into y minus k. For this parabola, which is in the shifted form, you can tell this as rotated and shifted form. X minus h the whole square equal to 4a into y minus k. Tangent equation is, the equation of the tangent is x minus h is equal to m into, y minus k only. You can start from y is equal to mx plus c form. Okay, don't get confused. Y minus k is equal to m into x minus h plus c. C is minus am square. Normal to this parabola is y is equal to, instead of y, got y minus k. Y minus k is equal to m times x minus h. Instead of y equal to mx, alright, y minus k equal to m times x minus h plus c. C is 2a plus a by m square. 2a plus a by m square over. So simple. This c is equal to, just remember the condition for tangent c for y square is equal to 4x is c equal to a by m. From there I modify and write. Okay, c is equal to a by m, c equal to minus 2am minus am cube, c equal to minus am square, c is equal to 2a plus a by m square. All those things you should remember. Okay, in the standard forms you should remember condition for tangent c. Okay, by remembering that c is in the standard form. Remembering that the tangent condition for y square is equal to 4x, y square is equal to 4x, condition for tangent c is equal to a by m, c is equal to a by m. This is condition for tangent c, for tangent, and c is equal to minus 2am minus am cube. This is for normal. This is for normal. Y square is equal to 4x. Remembering this, alright. And for x square is equal to 4ay. For x square is equal to 4ay. The condition for tangent is c is equal to minus am square. And for, this is for tangent. And for normal, c is equal to 2a plus a by m square. C is equal to 2a plus a divided by m square, which is normal. Tangent normal. Tangent normal. For y square is equal to 4x, x square is equal to 4ay. So writing the equations of tangent and normal for different parabolas in different forms we learned. Next I can go to the chord of contact. Chord joining the point of contact of the two tangents drawn from an external point is called as chord of contact. Okay, it's one of the most important concepts, the chord of contact. What is chord of contact? The chord which joins the point of contact of the two tangents drawn from an external point is called as chord of contact. The chord joining the point of contact, the chord which joins, the chord which joins the point of contact of the two tangents, point of contact of the two tangents, point of contact of the two tangents drawn from an external point, drawn from an external point, drawn from an external point is called as the chord of contact, is called as the chord of contact. The chord which joins the point of contact of the two tangents drawn from an external point is called as the chord of contact. Suppose you consider the parabola y square is equal to 4ax in this form. The chord which joins the point of contact of the two tangents is the chord which joins the point of contact of the two tangents drawn from an external point P. Okay, from the point P x1 y1, from the point P x1 comma y1, two tangents are drawn at the point A and B. So AB is called as the chord of contact. AB is called as the chord of contact. The chord which joins the point of contact of the two tangents drawn from an external point is called as chord of contact. And the equation of the chord of contact is given by T equal to 0. Equation of chord of contact. Equation of the chord of contact is T is equal to 0. T represents the tangent to this parabola. If you consider this parabola as y square is equal to 4x, how to write the equation of tangent? Same way you write the equation of the chord of contact. Replace y square by y1 and replace x by x plus x1 by 2. 4a into x plus x1 by 2. That is 2a into x plus x1. Equation of chord of contact. Equation of chord of contact is this. Same as you write the equation of tangent. For tangent, the point P x1 y1 lies on the curve. Here it is not on the curve. It is outside the curve from an external point. So the chord which joins the point of contact of the two tangents PA and PB are the two tangents drawn from an external point. So chord which joins the point of contact of the two tangents drawn from an external point is called as chord of contact. Equation of chord of contact is nothing but T equal to 0, which is nothing but same as writing the method of writing is same as that you write the equation of tangent, but the point is outside the parabola, not on the parabola. For tangent, the point lies on the parabola. For chord of contact, the point lies outside the parabola. That's the important thing. So don't think both are same. Chord of contact and the equation of tangent not one and the same. The method of writing the equation of the chord of contact is same as the method of writing the equation of tangent. That is the thing here. So equation of the chord of contact is good. And length of the chord of contact also given the formula. Length of the chord of contact is length of the chord of contact. Length of the chord of contact is given by L is equal to 1 by mod A into root of y1 square minus 4ax1 y1 square minus 4ax1 into y1 square plus 4a square. This is the length of the chord of contact. If possible, remember this. 1 by mod A into square root of y1 square minus 4ax1 into y1 square plus 4a square. Okay, if possible you can remember it, otherwise we can find the actual method and write the answer. Root of y1 square minus 4ax1 into y1 square plus 4a square. Okay. And also I can write the point of contact, okay, for this. Here we wrote no equations of tangent and normal. I can write the point of contact for this parabola as well as this parabola. For tangent and normal, both I can write the point of contact. Here I wrote the point of contact for this parabola. So suppose you want to write the point of contact for this y minus k whole square equal to 4 into x minus h. Add h to x coordinate, add k to y coordinate. Add h to x coordinate, add k to y coordinate. Okay, x square is equal to 4ay. This is also point of contact. Add h to this, add k to this. Tangent also, add h to this, add k to this, we get point of contact for y minus k whole square equal to 4 into x minus h. In this, you add h to x coordinate, add k to y coordinate, we get point of contact for x minus h whole square equal to 4 into y minus k. Even that can be got. Okay, so chord of contact, length of the chord of contact. Next we got chord bisected at a point. Chord bisected at a point. Chord bisected at a point. Equation of the chord which is bisected at a given point is given by t equal to s1. T is equal to s1 is the equation of the chord bisected at the point. T represents the tangent, s1 represents the point x1, y1, which is substituted in the parabola y square is equal to 4x. Equation of tangent y1 minus 2a into x plus x1. For y square is equal to 4x I am writing. For y square is equal to 4x, I am writing for this parabola. For y square is equal to 4ax. The equation of chord bisected at a point is t equal to s1. S1 means substitute the point in the equation of the parabola. y1 square minus 4ax1. Equation of the chord bisected at a given point. Okay. And also we can speak of the diameter to the parabola. The locus of the midpoint of the system of the parallel chords represents the diameter to the parabola, and the equation of the diameter is y is equal to 2a by m. Okay, diameter to the parabola also I can give you. Locus of the midpoint of the system of the parallel chords. Locus of the midpoint of the system of the parallel chords. Locus of the midpoint of the system of the parallel chords. Is the diameter to the parabola. And equation is given by y is equal to 2a by m. Its equation is for the standard form y square is equal to 4ax I can tell. Its equation is y is equal to 2a divided by m. For y square is equal to 4x for the standard parabola. And if two perpendicular tangents are drawn to the parabola, they intersect on the directrix. One of the most important property we have. If two perpendicular tangents are drawn to the parabola, where do they intersect? They intersect on the directrix. Result we can take here. The two perpendicular tangents drawn to the parabola intersect on the directrix. The two perpendicular tangents drawn to the parabola, two perpendicular tangents are drawn to the parabola will intersect on the directrix, on its directrix. Next, I can also discuss about the point of intersection of the tangents to the two parabola and point of intersection of two normals to the two parabolas. To the parabola. A parabola is given to you. You draw two tangents. Where is the point of intersection of the two tangents? The point of intersection of the two tangents, POI, is point of intersection of two tangents is given by AT1 T2 comma a into t1 plus t2. How to remember? The remembering method is there. We know the parametric equations of the parabola y square is equal to 4x is at square comma 2at, at1 square comma 2at1. Another point you write it as at2 square comma 2at2. If you take the geometric mean of at1 square and at2 square, they get at1 t2. If you find the geometric mean of a t1 square and a t2 square, what do you get? Geometric mean is root of the product of those two, a t1 square into a t2 square, a into a square. Root of a square is a, assuming that a is positive. Root of t1 square is t1, root of t2 square is t2. The geometric mean of the x coordinate is x coordinate of the point of intersection of the two tangents, and arithmetic mean of these two. Find arithmetic mean. Arithmetic mean of what? 2at1, 2at1 and 2at2. The arithmetic mean of these two is 2at1 plus 2at2 divided by 2. How much? 2 cancels, a is common, you get t1 plus t2. So the arithmetic mean of the y coordinates is the y coordinate of the point of intersection. If you take the arithmetic mean of the y coordinate, we get the y coordinate of the point of intersection of the two tangents. So point of intersection of the two tangents is a t1 t2 comma a t1 plus t2. Similarly, I can write the point of intersection of two normals to the parabola. Point of intersection of two normals. Point of intersection of the two normals for the parabola y square is equal to 4ax. I'm writing for the parabola y square is equal to 4ax. Point of intersection is 2a plus a into t1 square plus t2 square plus t1 t2 comma minus a into t1 t2 into t1 plus t2 minus a t1 t2 into t1 plus t2, where t1 and t2 are the parameters. This is point of intersection of two normals for y square is equal to 4x, and this is for also point of intersection of two tangents for y square is equal to 4x. For tangents this is, and this is for two normals, the point of intersection 2a plus a into t1 square plus t2 square plus t1 t2 comma minus a into t1 t2 into t1 plus t2. Okay. And one more thing I can give you a result is, if the chord, it need not be the focal chord, if a chord is going to subtend an angle of 90 degree at the vertex of the parabola, then we have t1 into t2 is equal to minus 4. It need not be focal chord, okay. In this case, it need not be focal chord, just a chord. A chord which subtends an angle of 90 degree at the vertex of this parabola will satisfy the condition that t1 into t2 equal to minus 4. If a chord PQ subtends an angle of, if a chord PQ subtends an angle of 90 degree at the vertex of the parabola, y square is equal to 4ax of the parabola, y square is equal to 4ax, then what we have is t1 into t2 is equal to minus 4. P is, this point is t1, t1 means at1 square comma 2at1, q means at2 square comma 2at2 for this parabola. Y square is equal to 4x. Of course, the directrix is here, x is equal to minus a for this. So various things I discussed. Okay, this is standard result I can take. Okay, if a chord, it need not be a focal chord, some chord PQ is going to subtend an angle of right angles 90 degree at the vertex of the parabola, then it satisfies t1 and t2 equal to minus 1. Product of the parameters is equal to minus 4. t1 into t2 equal to minus 4. Okay, You can prove it using the concept of slope. Find the slope of OP, find slope of OQ, then use condition for two lines to be perpendicular, M1 into M2 equal to -1. You get the answer. Okay, so point of intersection of the two normals also given, point of intersection of the two tangents, and also chord bisected at a point equation, and also given diameter to the parabola and chord of contact, length of the chord of contact, and writing the equations of tangent and normal to different parabolas in slope form, parametric form, point form, position of the point with respect to parabola, standard result when equilateral triangle is inscribed in the parabola with one vertex at the vertex of the parabola. The length of the side is going to be 8a root 3, all those things. Length of the focal chord in terms of the slope, angle alpha, correct, all those things, where alpha is the angle made by the focal chord with the positive x-axis. You can write a sentence there where alpha is angle made by the focal chord with the positive x-axis. Angle made by the focal chord with the positive x-axis. Segments of the focal chord, very important. Harmonic mean of the segments of the focal chord, length of the focal chord in terms of the parameter, various things I've discussed in this briefly. Okay, parametric relationship between the endpoints of the focal chord, at square comma 2at is one end of the focal chord, other end is a by t square comma minus 2a by t. Okay, all these things I have told. And one more thing I want to tell is normal drawn to the parabola at one point means the parabola again another point is given by relationship between T1 and T2, relationship between T1 and T2. It's one of the most important results, even though it's deleted, it's like better to learn. Relationship between T1 and T2, relationship between T1 and T2. If normal drawn to the parabola, normal drawn at one point, normal drawn at one point, meets the parabola at another point. Normal drawn at one point to y square is equal to 4x meets the parabola again. Normal is drawn at t1, okay, meets the parabola again. Relationship between t1 and t2, normal drawn to normal drawn at one point is T1 I'll take, normal drawn at one point T1 to this parabola means the parabola again at T2, then we have T2 is equal to minus T1 minus 2 by T1, T2 is equal to minus T1 minus 2 by T1. Relationship between T1 and T2, normal drawn at one point T1 to this parabola meets the parabola again at T2. We have T2 is equal to minus T1 minus 2 by T1. Okay, that is the most important thing. Position of the point, all those things we explained. Okay, different forms of the parabola, components, parametric relations, parametric equations, different important points connected to y square is equal to 4x, and finding center of the conic. Eccentricity of parabola is 1. Okay, that is you have to remember. Okay, and different terms used and how to distinguish between different conic given a general second degree equation. H square minus AB 0, delta is not equal to 0. The delta is called the discriminant of this above equation, general second degree equation. So with this, all the points connected to parabola, formulas and concepts have been completely covered, which is required for various competitive exams. With this, many more videos will be uploaded in the coming days. Please subscribe to my channel, Abhiram's Maths Marathon, for KCT, even KCT series. PYQs I've done from 1984 to 2025. Synopsis for each and every chapter will be done, okay, along with PYQs, and also a test paper I'm going to discuss for each and every chapter. And JEE also 2026 January sessions, I'll be covering the all the PYQs. Many more videos will be uploaded. Even the important questions like 2 marks questions, 3 marks questions, MCQs for board exams will be uploaded in the coming days. Please subscribe to my channel, forward to your friends. With this I conclude. Thank you.